Welcome. Are you battling with how to answer physics questions? I'm here to support you. I understand how you are feeling. You are not alone. There are many students who are feeling that like that. Having taught this subject for over 7 years, I know area students find it difficult to answer when it comes to Cambridge International exams. Today, we want to answer October-November 2024 Paper 2 Variant 1. I want you to look at how I'm going to answer the question one by one so that you can get some ideas from it while you are answering your questions. Let's move straight to question number one. Question number one. Define density. Density is the ratio of mass per unit volume of a substance. B. Figure 1.1 shows a cubical glass block. A student measures the mass of the block and the side lengths x, y, and z. The measurements are shown in table 1.1. Determine the density of the glass. Having said that density is mass per unit volume, it's important for us to use that to answer the question. The values again, mass is given to us, volume will be length times breadth times height. We will change it from centimeter to meter. Let's answer that quickly. Density equal to mass over volume equal to mass divided by length times breadth times height. And this will give us 0.243 divided by 5.41 times 10 raised to the power of minus 2 times 11.09 times 10 raised to the power of minus 2 times 1.62 times 10 raised to the power of minus 2. This will give us 2504.76. This is our answer. It's important when you try yours, you compare it. Now, let's go to the percentage uncertainty in the density. It's important for us to remember the formula that percentage uncertainty will be the percentage uncertainty of mass plus the percentage uncertainty of length plus the percentage uncertainty of breadth plus the percentage uncertainty of height. Once we get this, we add them together. Let's look at the values. Since this is in centimeter, the uncertainty is also in centimeter, we will not bother to change. So here, let's do it here as we get back to write the answer. This will be 0.001 over 0.243% plus 0.01 over 5.41% plus 0.01 over 11.09% plus 0.01 over 1.62%. Why I'm putting it up, once we do it this way, it's easier for us to get the answer rather than converting it from one part to another. So this will give you 1.3%. 1.3%. So this is 1.3. The true value of the density of glass is different from the answer in BI because of systematic error in the measurements. The first question you ask yourself is, what is systematic error? It's an error that occurs in a measurement consistently. The key word is consistently. We don't use we don't use average to remove systematic error. One of the things that could lead to systematic error is zero error from the vernier caliper. If there is any issues with the vernier caliper, it didn't start from zero. It can lead to zero error. That will affect the thickness. Another issue that can lead to it is also incorrect calibration of the caliper or the balance. You can pick any of them to write. Take note of this. This is not just for this paper, it's for other papers as well. You can pick one because it is 1 mark. The next question number 2. Define linear momentum. Linear momentum is the product of mass and velocity of a body. The product of mass and velocity of a body. Let's take note of that. Question B. A car of mass 1,800 kg is moving in a straight line. Figure 2.1 shows the variation with time of the momentum. Calculate the maximum speed reached by the car. Now we have momentum against time. For us to find the maximum speed means that they are looking at this point. Let's first trace it to know the value of momentum at that point. Okay, this is 6 and this is 8. That should be 6.2, 6.4, 6.6, 6.8, 7, 7.2. This is 7.2 times 10 raised to the power of 4 because there is 4 here. Maximum speed. Momentum equal to mass times velocity that we said. At maximum speed, we have momentum to be 7.2 times 10 raised to the power of 4 equal to, the mass is 1,800 V. Our V will be 7.2 times 10 raised to the power of 4 divided by 1800. This gives us 40. Our maximum speed at this point is 40. Take note of that. Calculate the maximum kinetic energy of the car. Since we have found our maximum speed, we can use that to find our kinetic energy. Our kinetic energy is half mv squared. This will give us 1 over 2 times 1800 times 40 squared. This is 1.4 times 10 raised to the power of 6 joules. Don't forget to write your formula. Very, very important. It will attract a mark in all your answers. Make sure you write your formula. Show that the acceleration of the car at time t equal to 4 seconds is 5 meter per second. This is time t. If we trace it up, this gives us this point. What will be that value? This is 2. This will be 3. That means this will give us 3.6. 3.6 times 10 raised to the power of 4. We are looking for acceleration. Let's define how to get it done. Remember that force is equal to change in momentum with time. If we have that place to be 3.6 times 10 raised to the power of 4 divided by 4 being the time, this will give us 9,000 Newton. That is one aside. Remember, F equal to ma. We now put 9,000 equal to 1,800 A. A will now be 9,000 divided by 1,800. This gives us 5 meter per second squared. Determine the distance traveled by the car between times t equal to 0 and time t equal to 12. We are asked to find the distance of all this. For us to find that, since we have a maximum velocity, it can help us. Now, we know that distance is velocity times time. If we get this area and get this area, that should be pretty good because we have velocity that will guide us through. Now, for us to do that, we can say that okay, the area is half base times height since it is triangular in shape. Here we have 8 for the ascending on, here we have 12. This will give us the first area and the second area. 1 over 2, base here is 8, and we have height 40, plus 1 over 2 times 4, that is 12 minus 8 times 40. This will cancel this. We have 4 times 40 plus 2 times 40. This gives us 240 meter. 240 meter. Okay. Question C. On figure 2.2, sketch the variation with time of the acceleration of the car in B from t equal to 0 to t equal to 12. We were able to get the acceleration for these aspects. We need to get the deceleration. We need to get the deceleration. For the acceleration, we cut 5. So from 5 here to 8, acceleration which is constant will be horizontal line. Horizontally. It got to maximum. We will need to get the deceleration. For us to get the deceleration, we will use this. This is velocity initial and this is maximum. We can take it as momentum. The momentum, the maximum momentum there. Let me do it quickly by the side. We have F equal to change in P over T. That will be 0 minus 7.2 times 10 raised to the power of 4 divided by, we have here 12 minus 8. That is minus 7.2 times 10 raised to the power of 4 divided by 4. This will give us minus 18,000. That is our Newton. If we use F equal to MA, now A there will now be minus 18,000 divided by 1,800. This will give us minus 10 meter per second squared. This will be the deceleration for this aspect. Since it is deceleration, we are going to get it down. That is minus 10. We drag it down here, and this is what we will get. All right. If you have any question on it, kindly drop in the comment section. I will respond to it. Question number 3. State what is meant by work done by a force. Work done is the product of force and distance in the direction of force. Work done there, the product of force and distance in the direction of force. Question B. A block of mass m is respectively at constant speed. The vertical height gained by the block is delta h as shown. Derive an expression in terms of m and delta h for the change in gravitational potential energy of the block. State the meaning of any other symbols you use. Here, we know that movement weight is equal to mg. Having known that weight is equal to mg, we can say that work done equal to force times distance in the direction of force. Force in this case will be the weight, which is mg, times the distance change in h. This will give us mg delta h, where g is acceleration due to gravity. Question C. An electric motor has an input power of 900 watts. The motor takes 1 minute to lift a load of weight 240 Newton at a constant speed through a vertical height of 150 meter. Resistive forces are negligible. Show that the work done by the motor on the load in 1 minute is 36 kilojoules. We will make use of the formula that we said work done equal to the weight times the change in height. Now, they said a vertical height of 150. This will give us 240 times 150. This is 36,000 joules, equivalent to 36 kilojoules. Question II. Determine the useful output power of the motor. Power equal to work done over time. Our work done is 36,000. Our time, this is 1 minute. We change it to second. This gives us 600 watts. Use your answer in CII to determine the efficiency of the motor. Efficiency equal to useful output over total input times 100 over 1. Our useful output here is 600, while our total input is 90 times 100 over 1. This will give us 67%. Some of the power wasted in the motor is dissipated by the resistance of its coil. This dissipated power is 280 watts. The coil of the motor is made from wire of total length 23 meter. The wire has a cross-sectional area of 2.6 times 10 to the power minus 8 meters squared and is made from metal of resistivity 1.7 times 10 to the power minus 8 ohm meter. Calculate the current in the coil. We know that power is I squared R. Resistance is resistivity length over area. We are asked to find the current. Let's replace resistance with this. It will give us power equal to I squared times resistivity length over area. Invariably, current will be square roots of power times area divided by resistivity length. Let's substitute the values. Power is given to us as 280 times the area 2.6 times 10 to the power minus 8 divided by resistivity 1.7 times 10 to the power minus 8 and the length 23. This will give us 4.3 ampere. Make sure you take note of how I derive it and I substituted it. Your derivation attracts marks, your substitution attracts marks, your final answer attracts marks. Question number 4. Define the Young modulus of a material. Young modulus is the ratio of stress to strain of a material. B. A metal wire P that obeys Hooke's law is stretched within its limits of proportionality. On figure 4.1, sketch the variation of tensile force in the wire with its extension. The key point here is within its limits of proportionality. This will give us a straight line. A straight line. Take note of that. State the name of the quantity represented by the gradient of the line. Based on Hooke's law, force is equal to Ke. K is spring constant. That is what we will have. We write here spring constant. State the name of the quantity represented by the area under the line in figure 4.1. When a wire is stretched, it saves an energy because work is done, which is half Fe. And this is what we call elastic potential energy. Another wire Q is made from a material that has twice the Young modulus of the metal of wire P. Wire Q has the same volume as P, but it has double the area. The two wires are extended by equal tensile force within their limits of proportionality. State and explain how the extension of wire Q compares with the extension of wire P. It's important for us to take note of some of the words used here. Twice the Young modulus, same volume, meaning Y equal to, that is Young's modulus equal to force length over AE. And in this situation, it is said that the force is the same, which is the tensile force. You can say Young's modulus area extension over the length. This is what will guide us. It is also said that the volume in Q equal to the volume in P. What that implies is that the area length equal to, here the area is twice 2A. If it is 2A, it means that the length will be half of that of Q to keep the volume the same. Let's use this to substitute for that of Q and that of P to see the extension of P. This will give us Young's modulus of Q, area of Q, extension of Q over length of Q equal to Young's modulus of P is twice of Q. Area is twice the area. Extension, which is what we are looking for, divided by length will be half, 0.5, the length of Q. Let's cancel things out. Young's modulus cancel Young's modulus, area cancel area, length cancel length. We end up having that that of Q, extension of Q, is 8 of P. We can write that the extension of P will be extension of Q divided by 8. Let's write few things here which will give us the mark. First, we are going to say that the length of P, the length of Q is half we can see that the length of Q is half since they have same volume. Say same volume, meaning area is twice, length will be half. You have to state that. The extension will be 1 over 8 of the P. I have shown you how we arrive at that. And we are going to explain that the extension is proportional to the length and inversely proportional to area and Young's modulus. Once you state this, I have stated almost 4 points here. You have all your 3 marks from here. Question number 5. Potassium 40 undergoes beta negative decay to form a nuclide of element X. Particle Z is emitted during the decay. The equation for the decay is shown. State the values of P, Q, R, and S. Looking at P, here beta negative, this will be 40, so P is 40. Q, this is -1, that will make this Q to be 20. R, we know that is 0 because we have this is what is emitting. For S, I have written it already, -1. State the name of particle Z. Whenever there is beta negative antineutrino, electron antineutrino will be emitted. So this will be antineutrino. When it is positive, it will emit neutrino. State the name of the class of fundamental particle to which both the beta negative particle and particle Z belong. They belong to lepton family. Out of them, they are electron, electron neutrino, electron antineutrino, and positron. They are all under lepton family. Determine the quark composition of an alpha particle. Alpha particle is helium nucleus, that is 4-2. In this composition, it has 2 protons. It also has 2 neutrons. For a proton has up, down. So 2 proton will be 2 of up, down. A neutron has up, down, down. 2 will be up, down, down. Let's expand it. This will give us 4 ups and 2 down. Here will give us 2 up and 4 down. By implication, it means that if we add the two together, we will have 6 ups and 6 down. The quark composition for helium will be 6 ups and 6 downs. Take note of that. Question number 6. Two coherent sources X and Q. Question number 6. Two coherent sources X and Y of microwaves of frequency 2.5 times 10 raised to the power of 10 H are a distance of 0.18 meter apart in a vacuum as shown. There is a phase difference of 90 degrees between the waves emitted at the two sources. A microwave detector moves along the line PQ, which is parallel to the line joining the two sources and 2.3 meters away from it. Point O is on the line PQ at a position that is equidistant from the two sources. Point A is the position on line PQ where the intensity of microwaves is the greatest. Explain why the position of greatest intensity is not at point O. Originally, it's supposed to be here, but it is not here. Why? The reason is that it started with a phase difference of 90 degrees, meaning at that O, we don't have maximum intensity. Now, this is what you will write. From my explanation, you see that there is a phase difference of 90 degrees at point O. For maximum intensity, the wave must meet in phase, either 0, 360, or multiple of that, meaning at 0 there, they didn't meet in phase. On figure 6.1, draw a cross to show the position of the points on line PQ where the intensity minimum that is the closest to point O occurs. Label these points B. Since they didn't meet at this point and they meet at maximum here, it means that it will be below it. It will be below it. Take note of that. That is the closest before you have maximum. After that, you can have another one, which is not the closest. Show that the wavelength of microwave is 0.012 meter. For microwave, it moves with the speed of light. So F equal to or V equal to F lambda. If we have this, it simply means that the wavelength will be equal to V over F. And we have a frequency given to us as 2.5 times 10 raised to the power of 10. We will now put it here 3 times 10 raised to the power of 8 divided by 2.5 times 10 raised to the power of 10. This will give us 0.012 meter. For point A on line PQ, determine the difference in the distances traveled by the microwaves from X and the microwaves from Y. Since the image here has phase difference already of 90, that is a quarter of wavelength. That is a quarter of wavelength. For us to get that, that will be change in X equal to lambda over 4, which is 0.012 divided by 4. And this will give us 0.003 meter. That is the phase difference. Use the formula for the double slit interference of light to calculate the distance between adjacent intensity maxima on line PQ. The formula is X equal to lambda D over A. And we have our lambda, which is the wavelength, 0.012. The distance between is given to us as 2.3. 2.3 divided by our A, distance between the two, 0.18. 0.18. This will give us 0.15 meter. This is a common question. It's important for you to remember the formula. If you don't remember it, go back to your notes. Electricity. Question number 7. A. Figure 7.1 shows two resistors connected in series with a cell of electromotive force 1.5 volts and internal resistance 0.28. One of the resistors has resistance 1 ohm. The other resistor has resistance R. The terminal potential difference across the cell is 1.36. Show that the current I in the circuit is 0.5. It's important for you to remember this, that current for EMF with internal resistance is given as E over R plus R. E in itself will be IR plus IR. Let's look at the values given to us. We have the terminal potential difference. We have the EMF 1.5 equal to 1.36, which is given to us, plus We have I, R. R is given to us as 0.28. This will be the current equal to 1.5 minus 1.36 divided by 0.28. This will amount to 0.5 ampere. Calculate the combined resistance of the two resistors. Since we know that V equal to IR, we are asked to find R, which will be V over I. And this will be 1.36 divided by 0.5, what we calculated. This gives us 2.72 ohm, the total resistance. Use your answer in AII to determine resistance R. Having calculated this, we can find this. Since they are in series, total resistance will be R1 plus R2. Here we have 2.72 equal to 1 plus R. Invariably, our R will be 2.72 minus 1, giving us 1.72 ohm. The circuit in 7.1 is disconnected and the two resistors are reconnected to the cell, now in parallel with each other. Figure 7.2 On figure 7.2, complete the circuit diagram to show this arrangement. Here we are asked to complete it and they said it is connected now in parallel. This is what we will have if it is connected in parallel. In parallel connection, there is a distribution of current into each of them. This will be 1, this will be 1.72 ohm. These are the things we will have in parallel connection. Explain without calculation whether the terminal PD across the cell is now less, equal to, or greater than 1.36. Since we are asked without calculation, when resistors are connected in parallel, we have calculation like 1 over this equal to 1 over R1 plus 1 over R2. The implication there is that for parallel connection, the total resistance will decrease. Once the total resistance decreases, the amount of current that will flow will be more and less work will be required. And remember, PD has to do with the work done in taking a charge from one point to another. So we will say that the total resistance will decrease. This will cause more current to flow. Thus, PD will decrease. It will be less than 1.36. PD will be less than 1.36 volts. We come to the end of today's solving. You can see for those who have issues with electricity, notice that once we follow it one by one, we can answer the question very well. I want you to go back to my channel, look at some other questions that I have solved. That will give you a very good way to answer more questions. See you in our next video. Don't forget to subscribe so that once I drop a video, you can see it and learn as well. Share it with your friends, make comments, give a like, thumbs up, make comments so that it can go to other people as well. And see you in our next video.